Hi everybody. In this video, we are going to be talking about adding, subtracting, multiplying polynomials, and then dividing by a monomial. And then just a reminder, a monomial again is a polynomial, but it only has one term, which is why it's got that prefix of mono. So the first couple things we're going to do kind of just right up here, we're going to go through some reminders about what makes like terms. And so just a reminder, for combining like terms, you can only combine terms that have the exact same variables raised to the exact same exponents. And that's what, again, they are considered like terms if they have the same exact variables raised to the same exact exponents. So of the terms that are in this row, if you can circle or box or do some kind of color coding for which terms in there are like terms. So one I'm seeing, we've got 7x cubed, and you want to look for, are there any other x cubed terms? And I see one over here, so those would be considered like terms. And then I'm going to look for, do I have any other x terms? I don't see any other x to the first terms, so that one's by itself. How about any y to the first terms? And I see one over here, so I'm going to underline that one and this one. So those would be considered like terms. And then finally, we can look over here. Are there any other x squared terms? No. Are there any other y squared terms? No. So then let's look in the second line here. We're just kind of warming our brains up, trying to remind ourselves what like terms are before we get ready to add and subtract them. So we're asking ourselves, do we have any other a to the first terms? And we've got one here, and then we've got one way over here at the end. And then next, we want to look for, are there any other a squared b terms? Do we see any other a squared b terms? And I see an a squared b squared, but the fact that this has b to the second makes that a different term. And then we've got something close here, but it's a to the first b squared, so that one's not quite the same. And then finally, we've got it way over here of a squared b to the first. So let's look at the next one. We've got b to the first, and it looks like we've got a b to the first here, as well as right here, that negative 22. And then I'm looking at b to the third. There's no other b to the third terms. Are there any other a squared b squared? No. And then the a b squared, there's no other like terms either. So we've identified all of our like terms. So here's what we're going to do first. We are first going to be working on this topic of 11.2.2, adding and subtracting polynomials. So that's what we're going to do for the first several examples. And that's what we're going to be doing the rest of this page and the next page. We're going to be adding and subtracting polynomials. Ooh, excuse me. And then we are going to be multiplying them. And then our last several examples will be dividing by a monomial. All right, so let's finish up this video with a ton of examples here. So our first example is going to be, we've got 4x squared minus 12xy plus 9y squared minus 32y squared plus 25x squared plus 4xy. And so what we're asked to do again is just to look across that polynomial and say, do we have any like terms that we can combine? And we do. We've got an x squared here and an x squared way over here. We have an xy term here, and we've got an xy term way at the end. And then finally, we've got our y squared terms. There's one right here, and then there's another one. And so those are going to be the terms that we can combine. The next thing that my brain is thinking about is between those three, like we've got an x squared, we've got an xy, and we've got a y squared, which one alphabetically comes first? Because we're going to have to put them in alpha descending order. So which one alphabetically comes first? And it's going to be this x squared. Then it's going to be the xy. Then it's going to be the y squared. So I want to combine my x squared terms first. So I'm looking at 4x squared plus 25x squared. So I'm taking those coefficients and I'm combining them. So 4 plus 25 is going to give me 29. Excuse me, 29x squared. And then we are going to be combining our next xy terms. So we've got a negative 12 plus a 4, which is going to give me a negative 8xy. And then finally, I'm doing these last two where it's a positive 9 minus a 32. And again, you're just combining those coefficients and you're going to end up with negative 23y squared. And then that's your final answer, okay, because we can't combine anything else. So we're going to go ahead and circle or box up that final answer. And that's as far as we can go with that one. So let's check out the next one. So if we have got a quantity of negative 5a plus 7 plus 4a cubed minus the quantity of 8a cubed minus 2 minus 3a squared. And again, we're just asked to simplify and combine these. So let's first look at our first set of parentheses. Is there anything for us to combine? Are there any like terms? And the answer to that is no. So then we look at our next set of parentheses. Is there anything for us to combine? Do we have any like terms? Again, the answer is no. Yes, we have an A and an A, but they're raised to different powers. This one's a to the third and this one's a squared. So again, they don't have the exact same exponents, so they're not like terms. So my next thing I'm going to do in my next line is I'm going to drop the parentheses for these three terms, because if I can't combine anything in those parentheses, I don't need those parentheses anymore. So I'm just going to write negative 5a plus 7 plus 4a cubed. And then I'm going to distribute this negative into my parentheses. Again, don't forget, if it's easier for you to think about kind of writing like a -1 in there, you definitely can do that. And then negative times a positive is going to give us negative 8a cubed. Negative times a negative here is going to give us a positive 2. And then negative times a negative is going to give us a positive 3a squared. Now I'm ready to think about how am I going to combine my like terms? Which one am I going to list first? And we should be listing the a cubed term first, because alphabetically the a cubed, a squared, a are all going to be the same, but we're going to put them in descending order. So we've got, excuse me, a cubed first, then a squared, then a, then our constant term in terms of the order that we're going to put them in. So I'm going to go ahead and say, well, what's a positive 4 minus an 8, which is going to give me a negative 4a cubed. And then now I've got this plus 3a squared I can plop on. And then minus a 5a. And then finally I've got a 7 and then a 2. So that's going to be plus 9. And then that's our final answer, because we can't do anything more of that. That's as much as we can combine. So let's check out our next example. We've got, so this one's kind of a long one. We've got 8a cubed b squared plus 6a squared b minus 4b squared plus 5. Then we are adding 10a squared b minus 4a cubed b squared plus 6a squared minus 7. All right, so we're going to do the same thing. I want you to look at the first set of parentheses, see if there's anything you can combine. Check out the second set of parentheses, see if there's anything you can combine, and then combine the two quantities together. All right, so let's see if there's anything in the first set. I don't see any like terms. There's no other a cubed b squared term. There's no other a squared b term. There's no other b squared. Now let's look at the second set. We've got an a squared b, a cubed b squared, a squared, and then a 7. There's nothing for us to combine. In addition, we have an addition sign there as opposed to a subtraction sign like what we did up here. So it's as if we are distributing a positive 1 to each of these, which gives us back exactly those same terms. So what that means is that I'm essentially just adding all of these terms together. And so I'm just going to rewrite them because the first set of parentheses does me no good. So I'm going to have 8a cubed b squared plus 6a squared b minus 4b squared plus 5 plus 10a squared b minus 4a cubed b squared plus 6a squared minus 7. Now I'm ready to look across that whole horizontal line and find out where my like terms are and kind of group them up and figure out which one alphabetically is going to come first. So alphabetically, go through all of the terms. Think about our filing cabinet. Which one would come very, very first? And it should be this a squared term all by itself. So we are going to put that 6a squared at the beginning. Then our next one, where I'm going to be looking at the fact that we've got an a cubed b squared and see if I see another a cubed b squared. And it looks like we've got one right here. So we've got an 8 of them minus 4 of them is going to give me plus a 4a cubed b squared. And then let's look for our next one. It looks like we've got this 6a squared b, and we've got an a squared b term here. So if I've got 6 plus 10 of them, I've got plus 16 a squared b. And then let's look, I've got a negative 4b squared here. And then finally, I've got a positive 5 and then a negative 7. So it's going to be a minus 2 finally at the end. And that's going to be your final answer. And sometimes I've had students say, well, is it okay? Like, it kind of makes more sense to me to think about 6a squared maybe coming after the 4a cubed b squared, and then it should be plus 6a squared. And then I'm sorry, this should be a squared b right here. I forgot my b. So make sure you put that on there. I just forgot to write it. So would it make more sense to put the a squared b or the 6a squared right here? And that's fine. Like, you could have written 4a cubed b squared plus 6a squared plus 16a squared b minus 4b squared minus 2. That would be another way to write your answer. And either one of those would be totally fine. Let's try another one before we start multiplying. So our next one, this is another subtraction one. We've got 3x to the 4th y cubed minus 2x squared y squared plus 5x cubed y squared minus the quantity of negative 1 plus 4x cubed y squared minus 2x to the 4th y cubed minus 2x squared y to the 3rd. And then that's the end of the parentheses. So it should be close off parentheses there. All right. So again, evaluate inside your parentheses. See if there's anything for us to combine. I don't see anything for us to combine. So now our next step is to distribute that negative into each of our terms in that second set of parentheses. So then I'm going to have 3x to the 4th y cubed minus 2x squared y squared plus 5x cubed y squared plus 1 minus 4x cubed y squared plus 2x to the 4th y cubed plus 2x squared y to the 3rd. So I'm going to make sure I just wrote that in right. So we've got a positive and then a negative and then a positive and then a positive. Make sure I copy down all my exponents right, and it looks okay. All right, so now let's look across that whole row and let's see which ones we can combine. So we've got an x to the 4th y cubed here. Looks like there's another x to the 4th y cubed there. So it's going to be 3, 4, 5 of them. 5x to the 4th y cubed And then let's look for an x to the third y squared. And it looks like we've got another one right here. So we've got 5 of them minus 4 of them will leave me 1. So I don't need to write plus 1 x cubed y squared, because again, you don't need to write the 1 in front, but we can just write plus x cubed y squared. And then our next one, let's see what's going to come next. We've got an x squared y squared, and then an x squared y to the third. So we can't combine them. So now we've got to figure out, well, which one's going to come first. And they're both x to the second power, but the y's have different exponents. So this one's going to come first. So it's going to be plus 2x squared y to the third minus 2x squared y squared. So we're done with that one. We're done with that one. And then finally, we just have this plus 1 at the very end. So we can just add that plus 1 on and then circle and or box your answer. All right. Let's try our first multiplication one. So when we're multiplying, this time we are multiplying by a monomial. So we're taking a trinomial and we are going to multiply it by a monomial. So we've got 5x times 4x squared plus 3x plus 7. So this is our first multiplication one. And we're going to do the property of distribution. So we're going to distribute this in. So we are going to take the 5x and we're going to multiply it by 4x squared. Then we're going to take the 5x and multiply it by 3x. Then we're going to take the 5x and multiply it by 7. So I'm going to write out the step here for what we're doing. And we have to keep track of our signs. Like this is a positive, and then each of these are positives. So we're going to take a positive times a positive, which results in a what? A positive. So 5 times 4 is 20. And I'm sorry, let me write out the step, the extra step that I told you I was going to write out. So the first one would be 5x. Why aren't you working, pen? There we go. 5x times 4x squared, and then it's going to be plus because I'm taking a positive times a positive. Then it's going to be 5x times 3x, and then it's plus again because it's a positive times a positive. And then it's going to be 5x times 7. And now we're ready to use our exponent rules. So we're going to do 5 times 4, which is going to give us 20. And then we're adding our exponents. So 1 and 2 is 3. So it's going to be x to the third plus 5 times 3 is 15. X to the first times x to the first is going to be x squared plus 5 times 7 is 35. So then it's going to be 35x. And then that's our answer. We always are kind of looking at the end, is it in alphabetical descending order? And it is. It's in the right order. One other way I want to show you, and I'm going to show you this other way on other problems, is that we can do something called the table method. And so maybe I put the 5x on this side, and then I do 4x squared, and then I do 3x, and then I do 7. And so here in this box, I would do 5x times 4x squared, and that gives me 20x to the third. And then in this box, I'm doing 5x times 3x. So I'm doing 5x times 3x, which is going to give me 15x squared. And then finally, I'm doing 5x times 7. So I can do 5x times 7, and that's going to give me 35x. And then when you're done, you'd say, okay, well, that's a positive, and that's a positive, and that's a positive. And then you're writing your answer out so it looks exactly like we have right here. So you can do the table method, or you can just kind of show your arrows for what you're doing. And I had students ask me, do I have to show this line, the second line right here? No, you don't have to show that one. I just was giving you the extra steps for this example in case you have not done that skill in a while. So let me show you another one. So this time we've got a negative. We're going to do negative 7x squared times 2x minus 5x squared plus x. And so here again, let's go ahead and distribute. We're going to distribute into each of those terms. Be careful of your negatives on this one. So here we've got a negative times a positive, which is going to give me a negative, and 7 times 2 is 14. X squared times x is going to give me x to the third because you're adding those exponents. Then our next one, we've got a negative times a negative, which is going to give me a positive. And then I've got 7 times 5, which is 35. X squared times x squared, because you're taking x squared times x squared here, is going to be x to the fourth, because you're taking 2 plus 2. And then finally, you're doing a negative times a positive, which is going to give you a negative. And then it should be negative 7x to the third. And then we're kind of looking at our answers here at the end, and we're saying, okay, what do I have here? Is there anything here that I can combine? And we've got these two terms that we can combine. And then we also need to rewrite them in alpha descending order. So let's put this guy first. He's by himself. So it's going to be 35x to the fourth. And then we're going to do negative 14x cubed minus 7, which is going to give me negative 21x to the third. And that's your final answer for that. So you can circle or box up your answer. Let's try another one. So the next one, we've got 5x squared y squared times the quantity of 2x squared plus 5xy minus 10. So again, let's go ahead and distribute. And if you would prefer, you can totally do the table method on either one of these. So again, if you're doing the table method, it doesn't matter. You can either put the 5x squared y squared up top or over here. So 5x squared y squared, and then if you're doing 2x squared, and then 5xy, and then negative 10, you can definitely do it that way too. So that would mean our first term is 5 times 2, which is 10. X squared times x squared is going to be x to the fourth, y squared. Then here we're going to do 5 times 5, which is 25. X times x squared is going to be x to the third. Y times y squared is going to be y to the third. And then negative 10 times the 5x squared y squared is going to be negative 50 x squared y squared. And then finally, we are putting our answers in alpha descending order. We're seeing if we can combine any of them. And our final answer is going to be 10x to the fourth y squared plus 25x cubed y cubed minus 50x squared y squared. And then we circle or box that up. I've had questions before about like, well, why doesn't this one go in front? Like, why doesn't it get listed first? Well, we're looking at the exponents on the x's first. So first alphabetically, they're all xy, xy, xy. So then we look at the powers on the x's, and it's 4, 3, 2. And so because of that, 4, 3, 2, that's why they go in the order that they're in. All right. Let's try some more. So our next one, we are going to be taking a binomial times a binomial. So we're going to have x plus 4, and we are multiplying by 2x plus 2. So this one, we are doing something where we're just distributing twice. So we're going to take our first term, and we are going to distribute it twice into our binomial. And then we're going to take the 4, and we're going to distribute it. So we're going to distribute the 4 into that second set of parentheses. And that's it. That's what we're going to do. And that process right there is called FOIL. So FOIL, the F stands for multiply the first terms, which is going to be x times 2x. So that's like x times 2x. And then we've got O, which is going to be outside. So then you multiply the outside terms, which again is x times 2. And then we do the inside terms, which is going to be 4 times 2x, because here's the inside. 4 times 2x. And then finally, it's the last terms. So the last terms is going to be 4 times 2. And again, you can always use the table method for this as well. So if you prefer to use the table method, you can say, well, let me set up table method and I'm going to do x plus, well, and you can do x. Let me fix that. You don't have to write the plus. You can do x and then a positive 4, and then you're going to do 2x and then 2, and then you just do your table multiplication like we did over here. So we would do 2x times x here, which is going to give you 2x squared. Then you would do 2x times 4, so that's going to give us 8x. Then you're doing 2 times x in that box, that gives you 2x. And then you're doing 2 times 4 in this last one, which gives you 8. Typically, not always, but typically your like terms are going to be along the diagonal. So we're going to combine the 2x and the 8x, and then that would give us, for our first term, 2x squared plus 10x plus 8. And that would be our final answer. Now, if we are doing the FOIL method, so FOIL method, we're going to get the same exact answer. So the first terms, f is x times 2x. That gives us 2x squared. Then we're going to do x times 2, which is 2x. Then we're going to do 4 times 2x, which is 8x. And then we're going to do 4 times 2, which is 8. And now we're going to simplify and combine our like terms. So now we've got 2x squared plus, and again, this is 10x plus 8, and then circle or box your answer. So again, your choice. You can either do table method, you can do FOIL, whichever one feels more comfortable to you. It's great. Let's try another one. So now we've got 4x minus 10 times the quantity of 2x plus 3. So let's go ahead and FOIL that, or you can do the table method, whichever one you want. I would urge you to pause the video and see how you do on this one. And I'm going to go ahead and work it out right now. So I'm going to FOIL. So then the first term, we're going to get 4x times 2x is going to give me 8x squared. And then I'm doing 4x times 3, which is going to give me 12x. I've got a negative 10 times a positive 2x, which is going to give me negative 20x. And then I've got a negative 10 times a positive 3, which is going to give me a negative 30. Now I'm ready to combine these two middle terms. I've got an 8x squared. A positive 12 minus 20 is going to give me a negative 8x minus 30. And that's going to be my final answer. And if you did the table method, you should end up with the same exact answer as that one as well. All right, let me come over here and do number 10. So number 10, we have got 4x minus 7xy times 2y plus 3x. So again, if you're doing FOIL method, our first terms, 4 times 2 is going to give me 8. X times y is just going to give me xy. Then I'm going to do my outside terms. So I'm going to get 4x times a positive 3x, which is going to be plus 12x squared. Then I'm going to do negative 7xy times a 2y, which is going to give me negative 14xy squared. And then a negative 7xy times a positive 3x, which should give me negative 21x squared y. And now look across and see if there's anything that we can do to combine. And then we're also evaluating which ones, what are we going to write in alphabetical order? Which one comes first? How do we put them in descending order? So the one alphabetically that should come first would be this one. And then we aren't able to combine any of these because none of them are like terms. So we're going to write 12x squared first. Here's our next one. That's the next term that would come in alphabetical and also descending order. So it would be negative 21x squared y. Then we're looking to the negative 14 because, again, you're looking at the x's, and the x's are to the same power. They're both x to the first. but the y squared, the 2 on the y here, says that negative 14 would come first. So it's going to be negative 14 xy squared plus 8xy. And that's your final answer. So that one was really, can we multiply correctly? Can we put them in alpha descending order? Let's try this one. So this one, if we've got 2b minus 3 quantity squared, what would that look like? And again, this does not equal 4b squared plus 9. So it does not equal that. So what we should do instead, let's take this quantity and we are going to expand it. So because we don't want to just distribute that 2 in, because that would not be correct. So we want to FOIL that instead, and we're going to write it out. We're going to do 2b minus 3 times the quantity of 2b minus 3. And now we're going to FOIL that out. So we're going to FOIL here. So our first terms, we're going to do 2b times 2b, which is going to be 4b squared. Then we're going to take 2b times the negative 3, which is negative 6b. Then we're going to do a negative 3 times a positive 2b, which is going to give us another negative 6b. And then we're going to do a negative 3 times a negative 3, which is a positive 9. Now we're going to combine our like terms here. So negative 6 and then a negative 6 is going to give us a negative 12b. So we've got 4b squared minus 12b plus 9. And that is our final answer with us combining our like terms. All right, I've got a couple more multiplication ones and then we switch into dividing. Number 12. Number 12. So this time we're going to take a binomial times a trinomial. So we've got 2p minus 1 times the quantity of 3p squared minus 3p plus 1. So this one, again, we're just going to be distributing. Take this first term, distribute it into each of those 3 terms. Take the second term and distribute it again into these 3 terms. So let's do that part first. We're going to go like this. Again, if you prefer table method, go for it. So you can set it up and you could do like 2p, could do negative 1, and then you're going to get 3p squared, negative 3p, and then a positive 1. And then ready, set, go. Go ahead and multiply that out. So 2p here times a 3p squared is going to give me a 6p to the third, because again, you're adding those exponents. 2p times a negative 3p is going to give me a negative 6p squared. Then a 2p times a positive 1 is going to give me a positive 2p. And then here we've got this negative 1 times each of these terms, which is just going to switch their sign. So I'm going to have negative 3p squared plus 3p minus 1. And now I'm ready to simplify and combine like terms. So 6p cubed is my only p cubed term. So that's going to go there. Then we've got negative 6p squared and negative 3p squared. That's going to give me negative 9p squared. Then I've got a plus 2 and a plus 3, which is going to give me a positive 5p minus 1. And that's going to be my final answer for that one. Number 13. Number 13 is similar. So I'm going to have you guys, after I write it up, I want you to try it on your own. And we're going to start with this one again, a binomial of 3x minus 2. And then we're going to multiply it by a trinomial of 2x squared plus 4x minus 11. And let me give you the answer, but I want you to try this one. So you should be getting 6x cubed plus 8x squared minus 41x plus 22. So that's what you should be getting when you're done. So pause the video, see if you can get that on your own, and then I'm going to show you how to do it too. And those of you who maybe prefer table method, I'm going to show you table method on this one, just so you have another way to check it out. So I'm going to do 3x and then -2. And then up here, I'm going to have 2x squared and then 4x and then a -11. So again, just a reminder, in this box, I'm taking 3x times 2x squared. So that's going to be 6x to the third. In this box, I'm doing 3x times 4x, which is going to give me 12x squared. And then in this box, I'm taking 3x times -11, which is going to give me -33x. So next row, I'm doing -2 times a 2x squared, which is going to give me -4x squared. -2 times a 4x is going to give me a -8x. And then -2 times a -11 is going to give me a +22. And again, typically, not always though, along the diagonals is going to be what you can combine because of like terms. And that's true of this one as well. So we've got the 6x cubed by itself. Then I've got a -4 plus a 12, which is going to give me an 8x squared. Then I've got a -8 and a -33, which should give me a -41x. And then finally, you are writing off your +22 at the end. And then you need to circle or box up your answer, because that's it. Okay, now we've got several more examples, but this time we are dividing. So if you are like me and you're running out of space, because it looks like we've got 5 more examples and we may not be able to fit them all in. So if you're running out of space for this too, please feel free to grab out an extra sheet of paper and you guys can add in your examples there if you're running out of room. So maybe just make a little bit of room here. All right. Let's try this one. So here we are dividing, and this type we have actually done a little bit of, where we've done some dividing, where we've taken a monomial and we're dividing it by another monomial. So let's say we've got 10y to the 5th and we are dividing it by 2y squared. So if we've got 10y to the 5th and then we're dividing it by 2y squared. So these, again, look at your numbers. How could we reduce these? A 10 over 2 would reduce to 5, right? Because 10 divided by 2 is 5. So I'm going to write, this is a 5, this is a 1. And then exponent rules. What do we do again when we've got y to the 5th over y squared? Hoping you remember that. We can subtract our exponents. So that's exactly what we're going to do. We're going to take those away, subtract them up here. And what do we have left in our numerator? We've got 5y to the 3rd all over, what do we have left in the denominator? All over 1, which is going to equal 5y to the 3rd. And that's our process of dividing by a monomial. All right, let's try our next one. So the next one, we've got -6r cubed all over 4r to the 4th. So again, just take your numbers, see how they can reduce. I'm going to take a 2 out, so that should be a 2, and this would be a 3. And then I'm going to subtract these 3 r's off. So what do I have left in the numerator? I've got a -3. In the denominator, I've got a 2r to the 1st, and I don't need to write r to the 1st. I can just write 2r for that one. So my answer is -3 over 2r. So our next one, we are going to take a trinomial, which is going to be 27y to the 4th plus 6y squared minus 18. And we are dividing that by -6y. And this one, I know it looks different, but I don't want you to give up on us. What we're going to do, we're going to make it look like our other 2 examples. So what I want you to do is that we are going to take this 27 y to the fourth, we're going to put it over negative 6y. Then we're going to take that positive 6y squared and we're going to put it over negative 6y. Then we're going to take that negative 18 and we're going to put it over that negative 6y. And I'm going to have you guys write it all out. So we are going to do negative 27y to the fourth all over 6y. Then again, you're paying attention to your signs. So positive over a negative is going to give me another negative. And I'm going to get 6y squared all over 6y. And then again, I've got a negative over a negative. So I'm going to get a positive. And I'm going to get 18 over 6y. And now you just need to reduce for like exactly what we just did on those top two examples. And you say, well, is there any way I can reduce 27 over 6? Sure, we can take out a 3. So let's take a 3 out. That's going to be a 9, and that's going to be a 2. I'm going to take this y to the first off up here. So my first term ends up being negative 9y to the third all over 2. Because the y's canceled out down here. Then let's look at the next one. 6 over 6 is going to reduce to 1. I'm going to take this y to the first and subtract it off up top. So what's left in my denominator? Just a 1. What's left in my numerator? A y to the first. So I would have negative, if I was writing it out, I would have negative y to the first over 1, right? Which would simplify to negative y. So that's what I'm going to write here. Negative y. And then let's do the next one. What would 18 over 6? How would that reduce? That would be 3. So this would be a 1. That would become a 3. So there's no other y's in the numerator. So my last term is going to be plus 3 over y for that last one. And that's my final answer. And I've got 2 more examples. And let me see if I can pull up something easy here, just to give me more space. I didn't want to do that. All right. So let's do this. We've got 30 t to the fourth minus 10 t to the third plus t squared minus 20 all over 10t squared. So write that one down and get it started. See how you do on that one. And what I want you to do for your first step is to take each of those terms in the numerator and put it back over 10 squared. So split it all up. That's the very first step I want to see on everybody's paper and in their notes. So we're going to do 30 t to the fourth all over 10t squared. Then I've got a negative over a positive, which is going to give me a negative. So I'm going to have 10 t to the third all over 10t squared. And then I've got a positive over a positive, so that's going to give me a positive. T squared all over 10t squared. And then I've got a negative over a positive, which is going to give me a negative. And it's going to be 20 over 10t squared. And now start simplifying and see what happens with our simplification. So 30 over 10 on this first one is going to give me 3. And then I'm taking these 2 off from up top. So you should be left with 3t squared minus, the 10s are going to reduce as to 1 over 1, right? I'm going to take these 2 off up here. And so what I would be left with was 1t to the first. So like if I write it out, I'd have 1t to the first all over 1. Well, that's just going to reduce to t, because 1 times t to the first is just t to the first. T to the first is just t, and t over 1 is just t. So that's what I get to write here. And then my t squareds over t squareds are going to cancel off, but what's left in the numerator? A 0 or a 1? And it should be a 1, because t squared over t squared is 1. So I'm going to get plus 1 over 10. And then our last one, let's take that 10 off. That becomes a 2 in the numerator. And it's going to be minus 2 over t squared. And that, my friends, is your final answer. And by the way, I have some students sometimes ask me, well, wait a second, I see a t squared there. Can I do anything with this t squared? No, because what would we, like, how would we express it if we brought that t up to the numerator? Like this term back here could also be written as negative 2t to the negative second power, right? So the negative second power is not the same as the second power, so you can't combine them. They're not like terms. All right, last example. So this one was number 17, by the way. And here's our number 18 and our last example. So this one we've got 14x cubed y squared minus 6x squared y to the fifth plus 2x y to the sixth all over 2xy squared for that one. So again, you should pause this video and see how you do on this one. You guys should, your first step should be to split it all up. Your answer, when you get done with it, you should be getting 7x squared minus 3xy cubed plus y to the fourth for your answer. So pause the video, see how you do, see if you get that answer, and then I'm going to go through it as well. And again, the first thing I want you to see on your paper is that you're putting each of those terms in the numerator back over the denominator. So I should see 14x cubed y squared all over 2xy squared. Then you've got a negative, because you've got a negative over a positive, so this is going to be a minus. 6x squared y to the fifth all over 2xy squared. Then you've got a positive, positive over a positive, so it's going to be positive. 2xy to the sixth all over 2xy squared. And now we're ready to reduce. So if we are reducing, the 14 over 2 is going to become a 7. So that would be a 7. And then I'm taking this x off right here. And then my y squareds totally cancel. Y squared over y squared is just 1. So that's going to cancel off. So I'm left with only a 1 in the denominator. And in the numerator, all I'm going to get is 7x squared. And that's it. So then I'm going to get negative. 6 over 2 is going to be a 3. And then we've got an x squared over x. So I'm going to take this one x off of the numerator. And then I'm going to take these two y's off up here to it as well. And so again, in the denominator, all I have is 1s. 1 times 1 times 1. So it's going to be all over 1. So I just need to look at the numerator. So I'm going to have 3x to the first, which is just x, y to the third. And then my next one, the 2's again are going to cancel, and I'm going to get 1 over 1. My x's are going to cancel, and I'm going to get 1 over 1. And I'm going to take those 2 off right up here. So again, in the denominator, all I have is 1 times 1 times 1, which is 1. So the only thing that's left in my numerator is y to the fourth. And that is our final answer. So circle or box it up. Again, if you guys have any questions, feel free to reach out to me, but that's the end of this video. So thanks for tuning in.